Hi everyone. Good afternoon to all of you. So I'm Lakshmi. Please do subscribe my channel MathLenie. Now I'm going to teach inverse trigonometric functions. First of all, you should get to know what is inverse of a function. So whenever f maps from a to b is a bisection, then only it is invertible. When do we say that it is bisection? If it is both 1 1 and on 2. So when do we say that it is 1 1? F maps from A to B is said to be 1 1 if different elements of A have different images in B. So in this case, this function must be a monotonic function. It must be either monotonically increasing or monotonically decreasing throughout the domain. Now when do we say that it is on 2? If every element of B occurs as an image of at least one element of A, then F maps from A to B is onto. Onto is also called sursection. So in this case, range must be equal to codomain. So whenever F maps from A to B is both 1 1 and onto, we can say that it is invertible. Then F inverse exists and is mapping from B to A is also a bisection. So now how can we define inverse trigonometric function? But all the trigonometric functions are not bisective mappings. So to make them bisective, we have to restrict both domain and codomain so that it is 1 1 and onto. We have to restrict the codomain so that it is onto. We have to restrict the domain so that it is 1 1. So how can we restrict both domain and codomain? Now let us discuss about inverse sine function. Inverse sine function. So for that reason, the function sine x must be a bisective mapping. Right? So we have to restrict the domain so that it is a strictly increasing function. That means monotonic. It must be monotonic throughout the domain. So let us draw the graph of sine x. Once look at the graph of sine x. So between minus pi by 2 and pi by 2 it is strictly decreasing. Between pi by 2 and 3 pi by 2 it is strictly decreasing. So we can choose either closer interval minus pi by 2 comma pi by 2 or pi by 2 comma 3 pi by 2 or closer interval 3 pi by 2 comma 5 by 2. So we can restrict the domain. So we can choose infinite number of domains so that sine x function is 1 1. So now I took only closed interval minus pi by 2 comma pi by 2. So I have chosen this as principal one. Now what about the codomain? Codomain must be equal to onto. It happens only when range is equal to codomain. We have to restrict the codomain so that it is onto, right? So in this here codomain must be equal to range. What is the range of sine function closed interval minus 1 comma 1? So f of x maps from closed interval minus pi by 2 comma pi by 2 to closed interval minus 1 comma 1 is a bisective sine function. Now its inverse is defined as closed interval minus 1 comma 1 to closed interval minus pi by 2 comma pi by 2. Obviously it exists and is also a bisective sine function. It is called inverse sine function or arc sine of x. It is denoted by arc sine x or sine inverse of x. Sine inverse of x. So here sine inverse maps from closed interval minus pi by 2 comma pi by 2 to closed interval minus 1 comma 1. Now how can we draw the graph of inverse sine function? First of all, draw the graph of sine x function in closed interval minus pi by 2 comma pi by, right? Now, so after that we have to reflect the graph of sine x in the line y is equal to x in order to get sine inverse x. Once look at the graph of y is equal to sine x, bisective sine function. Here this is a bisective sine function and let us draw the graph of sine inverse. How can we draw the graph of inverse sine function? Obviously it must be the reflection of y is equal to sine x. I mean bisective sine function in the line y is equal to x. Obviously it looks like this. So reflect the graph of y is equal to sine x in the line y is equal to x. So here we have to rotate the graph through an angle 180 degrees or else interchange both x-axis and y-axis. So the points on, the reflection of y-axis in the line y is equal to x becomes x-axis. The reflection of x-axis in the line y is equal to x becomes y-axis. That means we have to choose the points minus 1 and 1 on x-axis, minus pi by 2 and pi by 2 on y-axis. Now the graph of y is equal to sine inverse x looks like this, right? So it must be the reflection of bisective sine function in the line y is equal to x. Obviously it is an odd function. Sine inverse minus x is equal to minus sine inverse x. For all x belongs to closed interval minus 1 comma 1. Every odd function is symmetric about origin, okay, whose branches are in opposite quadrants. Next, how can we define bisective cosine function? Bisective cosine function. For that reason, first of all, we have to redefine the cos x. That means we have to restrict the domain and codomain of cos x function so that it is bisection. Here in closed interval 0 comma pi, it is a strictly decreasing function. Obviously it is 1 1, so we have to restrict the domain to closed interval 0 comma pi. Why? Because it is a strictly decreasing function. Now we have to choose codomain as a range. What is the range of the function? Closed interval minus 1 comma 1. Then obviously it is onto. Since it is both 1 1 and onto, so obviously cos x maps from closed interval 0 comma pi to closed interval minus 1 comma 1 is a bisection. Now cos inverse x, therefore cos inverse x exists and is mapping from closed interval minus 1 comma 1 to closed interval 0 comma pi is also a bisection. Exists and is also a bisection. Now obviously how can we draw the graph of y is equal to cos inverse x? It's a reflection of y is equal to bisective cosine function in the line y is equal to x. In the line y is equal to x. This is the line y is equal to x. We have to reflect this. Now I am going to draw the graph of y is equal to cos inverse x. It looks like this. Here we have to choose minus 1 and 1 on x-axis and 0 comma pi on y-axis. So the graph looks like this. This is a graph of y is equal to cos inverse x in closed interval minus 1 comma 1. Obviously it's a monotonic function in closed interval minus 1 comma 1, hence it is 1 1, and whole graph is in between 0 and pi. Obviously its range is closed interval 0 comma pi. This is the graph of y is equal to cos inverse x. It is never even nor odd function.